Hello everyone, my name is Abraham from Eurac Research Center for Sensing Solutions. I'm presenting the concept of enhancing water resilience in mountain agriculture method, H. H is the name of the second longest river in Italy. Eurac is a research center focused on alpine studies. We are located in the province of South Tyrol, north part of Italy, the pathway to the Alps and the Dolomites. The dramatic changes in orography here results in different climate areas and in consequence a variety of economical activities. Here you can see a glimpse of the type of landscape. The economy in South Tyrol mainly depends on agriculture, tourism, commerce, wood and forestry, and also energy production. South Tyrol produces wine and apples. 1 up to 8 apples that are consumed in Europe comes from this region. Therefore, the province extremely depends on water availability. The H River burns in the big mountain area in the province. The Ortlar group reaches up to 4,000 meters of elevation. The river flows first into the Finchgau Valley, where the most important economical activity is agriculture. The main production is apple. Agriculture consumes more than 70% of water, but paradoxically, this valley is the driest one in the entire province. The goal of the project is to monitor the basin of the H River for water management in mountain agriculture, but simultaneously, we want to provide evidence on how climate change is affecting the availability, quality, and accessibility of water. Here on the right, you can observe the changes in less than 2 centuries in the Ortlar Glacier. Here we propose a storytelling approach to communicate science to wider audiences based on the data collected from different sensors. We will collect data from different sources at different scales. With the support of expert modelers, we will create different products to understand water availability and the consuming mountain agriculture. The innovative part of this approach relies on the use of cosmic ray neutron sensors. These new instruments are able to detect moisture that is related to the soil moisture but also to the amount of snow. The footprint and sensitivity of this sensor is around 300 meters in diameter, overcoming the spatial limitation of in situ soil moisture probes and making them suitable to integrate into remote sensing products. We will fusion different sources of information using drones by mapping the snow fields. Having meteor stations to identify some variables such as temperature will support the research part to understand the phenomena. All the sensors will be connected in internet towards the IoT concepts. Further integration of remote sensing products to calculate soil moisture and drought will complement the datasets. We aim at creating the first network of cosmics at different elevations. Finally, assimilating the data into hydrology models to construct digital twins for actual and forecast conditions. In the past, we have used the cosmics for monitoring soil moisture with a very good results. We were able to map an area of 7 hectares. The last 3 years, we are monitoring snow fields in the mountains. The preliminary results show good correspondence to the standard point measurement. It means the snow height. The advantage of cosmic is the volumetric snow analysis in winter and the capacity to infer soil moisture in snow-free conditions, summer and spring. We will need to do some data analysis to relate the measurements to the snow water equivalent and therefore having the total amount of water. For longer observation in time, we would like to make the population aware on how the scarcity of snow availability is resulting in less and less water availability and impacting the groundwater reservoirs. This proposal aims to assimilate data from remote sensing products into a cloud-based system to derive specific models of water availability. Eurac has excellent experience in this domain from previous projects. The most representative one is the Alpine Drought Observatory that covers the entire Alpine area. The proposed method then integrates new technology at different scales into the data fusion concept. We aim at monitoring the second largest river in Italy. We will model such data towards the creation of digital models or twins of the monitored environment. The visualization part will transmit a message to the audience. Water scarcity affects and will severely affect alpine ecosystems and human activities if we don't start to optimize the use. We want to engage the public administration, such as the agriculture department, to make policies for the use of water. We want also to transmit the message to the stakeholders for tourism about the high impact of snow scarcity and how the production of artificial snow will affect the lowland water sets. Thank you very much for your attention. Looking forward to cooperate with you.